Well, that's the problem. The James Webb Space Telescope is upsetting the apple cart. All of a sudden, we realize that we may have to rewrite all the textbooks about the beginning of the universe. Now, it takes many billions of years to create a galaxy, like the Milky Way galaxy.
In light of this, our existing understanding of the universe will need to be revised. The ultimate cosmic hypothesis explaining our origins, the Big Bang hypothesis, is completely refuted by a discovery made by the James Webb Space Telescope. Neil deGrasse Tyson claims that black holes from a previous universe that created our own were found by the Webb telescope. All of a sudden, we realize that we might need to rewrite all of the textbooks on the origin of the universe because the James Webb Space Telescope is appending the apple cart. Is it time to revise our concept of the cosmos? If yes, what kind of impact will the changes have? Join us as we examine the perplexing discoveries made by James Webb. Is there any chance that the Big Bang measurements were inaccurate or incomplete? We shall find recently found galaxies that James Webb has disclosed. Developing the theory of the hot Big Bang is among the most significant scientific breakthroughs of the past century. This theory states that the universe began as a denser, hotter, and more uniform state. The discovery of the primordial fireball, now known as the cosmic microwave background, in the 1960s miraculously confirmed the notion, which had been put out as a credible alternative to the mainstream theories of cosmic expansion. For over half a century, the Big Bang theory has dominated efforts to explain the origin of the universe. Its foundation is an inflationary period preceding the Big Bang, but astronomers and astrophysicists have long raised concerns to both cosmic inflation and the Big Bang, and now the James Webb Telescope has found a new problem. James Webb contributed to the cosmic story by adding more depth. If it discovers early galaxies that are significantly bigger than anticipated, it may alter our understanding of the universe. James Webb's finding of these huge galaxies in the early universe suggests that our present understanding of the universe may need to be revised. Astronomical models in use today disagree with this discovery. The James Webb Space Telescope has only been in operation for a short while, yet already in that time it has provided previously undiscovered information about the universe in the first few 100 million years after the Big Bang. Because of the James Webb Space Telescope, everything is aflutter. We've just realized that all of the textbooks explaining the origins of the universe may need to be revised. One astonishing finding is the development of gigantic galaxies teeming with stars. 6 huge galaxies that were present throughout the early cosmos have been spotted by scientists using the James Webb Space Telescope's infrared sensing equipment. If these objects' size is confirmed, it might fundamentally alter our understanding of the origins of galaxies. The James Webb Space Telescope provided the data used in these findings, which were then published in Nature. The information depicts the state of the cosmos 13.5 billion years ago, or around 3% of its current age. What precisely are galaxies, if they are so mysterious? Only 500 to 700 million years after the massive explosion that marked the birth of our universe, mysterious galaxies with age indicators equivalent to our own Milky Way, which is 13 billion years old, first appeared. These celestial bodies have stellar masses several billions of times larger than our Sun. One potential monster has a mass of 100 billion times that of our Sun. Our Milky Way is home to stars equivalent to over 60 billion suns. To put it simply, the size of these galaxies dwarfs that of our own Milky Way. Astronomer ER Nelson of the University of Colorado Boulder, who co-authored the paper, expressed her disbelief and remarked that she finds it puzzling that such huge objects might develop so suddenly. We believe that this is an enormous finding, and it is a major discovery. Discovering unexpected and inexplicable objects requires us to re-evaluate our view of the cosmos, which makes it the most fascinating aspect of the amazing telescope we have sent into orbit. Contrary to popular belief, galaxies with star masses equivalent to the Milky Way developed quickly during the early universe. This unexpected discovery contradicts long-held cosmological theories, which hold that the creation of galaxies is a gradual process that starts with small star and dust clusters. The narrative goes like this: things in the early universe originated slowly, but it falls short of explaining the recently found enormous entities. The chief researcher, Evola, is intrigued by these creatures' apparent early maturity. Large galaxies in the cosmos are thought to have formed gradually, but this discovery casts doubt on that theory. Astronomers refer to these objects as universe breakers, a colloquial term that accurately describes their impact on our understanding of the universe's expansion. Astronomer Emma Chapman of the University of Nottingham in England says that if these results hold up, it might significantly change our view of the early universe, even though she was not involved in the research. Massive galaxies around the Big Bang have been found, which challenges the notion of a dark cosmic epoch and suggests that star formation may have started sooner than previously thought. Scientists caution us, nevertheless, before we start rewriting the history of cosmology. One idea suggests that some of these entities are hidden by supermassive black holes. The objects in the photographs that appear to be stars might instead be gas and dust falling due to gravity. It is still unknown how complicated black hole growth and expansion were in these early stages. Another scientist who is not involved in the research claims that the new data raises questions about how these objects expanded and were produced rather than casting doubt on cosmology. Scientists may employ spectroscopy to capture an image of the identified object's spectra, which would show their age, to validate their results. Their enormous redshift indicates that the light from these early universe galaxies has been stretched considerably on its journey to Earth. The galaxy is older and further away when the redshift is higher, since it means that the light has been stretched. Spectroscopy can provide information about how old these galaxies that have been classified as high redshift candidates are, as well as whether or not they are indeed naturally redshifted galaxies from a more recent cosmic epoch. Astronomers surmise that the observed mass represents a startling discovery, even if further observations are needed to confirm the findings. In any case, the known star mass from this cosmic era may be 100 times greater than previously believed, even with a 50% drop in the sample size. Michael Bohnkulken, a professor at the University of Texas in Austin, provides a unique perspective on the subject in Nature Astronomy. The most widely accepted cosmological model, known as lambda CDM, cold dark matter, postulates that dark matter and ordinary matter were heavily mixed in the early universe. As the dark matter halos collapsed, some of the entangled normal matter turned into stars, forming the earliest galaxies. The cosmic microwave background, according to Bohnkulken, offers compelling evidence for the dispersion of matter in the early universe. He set out to find out what proportion of ordinary stuff should be in order to match in with the high-mass galaxies discovered by James Webb. He came to the conclusion that nearly every atom in the cosmos would have been used in the production of starburst stars. However, Bohnkulken believes that this nearly flawless efficiency is not achievable. On the other hand, he asserts that the efficiency of the current universe is just about 10%. Mark Fogelberg of MIT welcomed the paper's theoretical approach, despite not being involved in the study. Vogelberger claims that the estimate's robustness is obtained from a relatively small number of assumptions. Is lambda CDM eliminated from consideration? Boylan-Kinn's calculations notwithstanding, he does not entirely dismiss lambda CDM, saying that no other theory can equal its power and that replacing it would only be a last choice. But are there any more potential causes at play here? Mysterious Discoveries, Haley Williams, who oversaw a team from the University of Minnesota, disclosed the existence of an intriguing early galaxy that was found only 500 million years after the Big Bang. The James Webb Space Telescope observes gravitational lensing amplification, which is another factor contributing to the galaxy's low appearance. Tens of times more stars are produced there than in galaxies from a slightly later era. Williams notes that while this galaxy is less in mass than the ones that Bohnkulken investigated, she speculates with some degree of accuracy as to whether or not galaxies at the same redshift that have bigger masses may also exhibit similar intensive star production. Even yet, Bohnkulken is still cautious because of how little the thing is. With a diameter of just 105 light-years, it is significantly smaller than the typical galaxy. He considers the possibility that it could be a globular cluster after all. One potential remedy for the cosmic model tension is to implement lambda CDM alterations. Changes in the behavior of dark energy immediately following the Big Bang are suggested by early dark energy. This adjustment might reconcile the discrepancies linked to the Hubble constant with other measurements. These hypotheses suggest that there was more matter in the early universe than there actually is. Bohnkulken's simulations in this scenario indicate that early galaxy matter concentrations would triple, negating the need for hyper-efficient star formation to achieve the same outcomes. Nonetheless, ED models assert that the universe is only 13 billion years old, in contrast to the 13.7 billion years inferred from other data. A second possibility is that stars have been incorrectly identified by astronomers as the source of some of the light in the galaxy. According to Boyle and Cullen, the light is most likely the result of accretion disks surrounding supermassive black holes. Having observed a limited sample of these galaxies to date, who believes that this is the most plausible explanation? The tiny sample size may not be representative of the entire universe, astronomers caution. Joel Leisure, a professor at Penn State who was not involved in the study, suggested that if comprehensive statistical surveys were carried out, the observed tension would disappear. Is it true, though, that these galaxies are so distant? A different researcher not engaged in Bohn Cullen's work, Peter Berui of the University of Arizona, noted that nearby low-mass galaxies can appear to be far-off giant ones. To get conclusive results, further measurements are required. Most critically, we still lack spectroscopic observations of these galaxies, which would be necessary to determine their true distances and search for black hole signatures. Michael Bohn Cullen believes that the severity of the issue will become evident in a few years, if not sooner, in light of fresh knowledge. To pass the time before we receive this information, we might examine the astronomers' theories on this event. This might be some sort of unidentified mechanism in action. Some scientists claim that this puzzle might be answered if we consider that massive black holes might have existed in the early universe. Astronomers will finally comprehend the existence of massive galaxies in telescope surveys if this assumption proves to be accurate. The problem is in explaining the abrupt increase in the number of black holes in the early universe. This is where a highly controversial theory advanced by a Nobel laureate becomes relevant. A challenge to credibility, the widely accepted theory of creation states that everything that exists or ever will exist was contained inside a single, infinitely dense point around 14 billion years ago. It was this singularity that erupted in the Big Bang and from which everything in the observable universe started. This is the degree of simplicity at which the Big Bang can be explained. Even still, a large number of scientists believe that 13.7 billion years is insufficiently lengthy for the evolution of complex structures like superclusters. A physicist at Oxford University is challenging the traditional Big Bang theory, arguing that the cosmos was formed only 300,000 years ago, and he plans to use cosmic microwave background radiation to support his claims. This scientist contends that the Big Bang did not mark the beginning of time, but rather was only one event in a lengthy sequence of comparable explosions known as eons. All these events signaled the beginning of a new era in the history of the cosmos. The idea put out by Roger Penrose, the 2020 Nobel Prize winner in physics for his research on black holes and mathematical techniques, states that our universe has seen several great bangs and that there will likely be more in the future. The Nobel Prize was awarded as a result of Penrose's contributions to the advancement of mathematical techniques. The general theory of relativity by Albert Einstein was strengthened and confirmed by these techniques. He examined the intricacies of black holes and demonstrated how dense things collapse under gravity to create singularities, or locations with infinite mass. When Penrose accepted the prize, he reiterated his outlandish suggestion and called it ridiculous. All stuff will ultimately dissolve as the universe expands, resulting in a fresh Big Bang and the creation of a whole new universe. Penrose said in an interview his strong conviction that something existed before the Big Bang and that something more for mankind is still to come. So how does the scientist support his theory, which he refers to as conformal cyclic cosmology? Sir Roger Penrose, who is questioning the current Big Bang theory, claims to have discovered 6 hot places in the sky dubbed Hawking points, each around 8 times larger than the diameter of the Moon. These points suggest the potential of black holes existing. They are named after the late Professor Stephen Hawking, who proposed the theory that black holes evaporate after releasing radiation. That being said, it is extremely improbable to have been witnessed at the universe's current age of 13.77 billion years. Penrose says simply that our world is not the first or the last, but rather that it developed into the complex reality we perceive from a highly organized, densely packed mass. A highly organized, low-entropy state at the beginning of the universe cannot be explained by the current inflation-based Big Bang model unless something extraordinary occurred long before the Big Bang. According to Penrose's hypothesis, As our universe nears its ultimate expansion into nothingness, it has and will once more return to a low entropy state, leaving behind a cold, black, featureless vacuum. Penrose suggested that dead black holes may be thought of as the remnants of past eons or universes. This may be confirmed, which would support Hawking's idea. In 2020, Penrose published a study in the monthly notices of the Royal Astronomical Society that included evidence of hot spherical anomalies in the microwave background. The information for these sites comes from the Planck 70 GHz satellite and was verified by over 10,000 simulations. Penrose, 2018, proposed that black hole vaporization might be the cause of radiation hotspots observed in the cosmic microwave background. The uniform temperature rings in the cosmic microwave background, CMB, are caused by gravitational wave traces from black hole mergers in an early universe, according to a 2010 Cyclic cosmology research by Penrose and V. Gordon. Black holes destroy stuff and release radiation, which lowers entropy. When the universe gets closer to the conclusion of its expansion, the remaining black holes will either merge or disappear, returning some sort of order. In doing so, the current jagged form of spacetime geometry is smoothed down, resulting in a condition reminiscent to the Big Bang. According to Penrose's idea, the universe will collapse into a highly ordered system when it stops growing, ushering in a new era that will end with the next Big Bang. Penrose argues that changes in the CMB temperature shouldn't be random, despite what the general public believes. In the NASA WMAP satellite data, he and Gordon found more than 12 concentric rings, which showed evidence of gravitational waves from millennia ago. Penrose's conformal cyclic cosmology, if verified, would rule away the need for a Big Bang precursor by indicating that our universe is only one among many, maybe infinite, eons old. Although it is up for discussion, the concept seriously challenges accepted wisdom in the field of cosmology and, if validated, might have far-reaching implications. Some people find it difficult to accept that the universe can change from being infinitely large in one instant to being exceedingly small in another, which implies that as the universe ages, particles must lose mass. Share your thoughts on whether Penrose's theory holds water or if it's another Big Bang notion that will fade into oblivion. For more, subscribe and leave a like.